So we're looking at section 2.3, which is solving quadratic equations. There's three methods of solving quadratic equations depending upon what the equation looks like. This is the first one. And let me give you an example of what it is before I actually state what it is. So we'll put that in a separate, we'll put all of them in a separate category up here and start down here. So this is the first type. It looks like this. Okay, so how do you know, first of all, that it's a quadratic equation? Is that it's got an equal sign, so that makes it an equation. It's a quadratic expression, so therefore it's a quadratic equation. The general form of a quadratic equation will be this. So in order to fall into the category of solving a quadratic equation, the quadratic equation has to look like this, or some variation of that, as we'll see when we move on. But this is an example, and we're going to use this to introduce the concept. And what we do is what we would normally do when we confront a trinomial, and that is we factor it. So, this is what we do. The x and the x, the two numbers that multiply to give you -12 and add up to -1, and that will be -4 and +3. So +3, -4 multiplied gives you -12, and when you add them, you get -1. Now, the thing is that at this point, you have two expressions that are being multiplied to get 0. So take a look at this. If you're multiplying any two numbers and you're getting 0, that means that either one of them will be 0 or the other one will be 0. So either or. And it could be both. It could be both of them are 0, but you have to take that into account. So you let one of them equal 0, and you let the other one equal 0. And then you just solve these, really simple equations. X equals -3 is one solution. And x equals 4 is the other solution. And to really feel comfortable and confident in this, we could check them. You could check both. You could check, now this is not required by me, but you could check one, you could check the other, you could check none of them and just say, well, this is what I got and that's it. But if you want to, just check yourself here, at least in the first problem that we do, use -3. Question mark, we don't know if this is true, but this is 9 plus 3 minus 12, we think is equal to 0. 12 minus 12 is 0. Yes, absolutely. Works perfectly. And if we put the 4 in, it's going to be 16 minus 4. So once again, 4 squared minus 1 times 4 minus 12, we think is equal to 0. 16 minus 4 minus 12, that works. This becomes 12, and 12 minus 12 is 0. Okay, so this is the check. And you could do that or not do it. It doesn't really matter. And the first type of solving, the first method of solving quadratic equation is by factoring. And I'd like to give you one to try on your own. Okay, so this is the method, and here is a typical problem. This is a little different. So I'm challenging you significantly by giving you the following problem. And the instructions, of course, are solve for x. And I'll give you a few moments to tell you the truth. Now, the first thing we need to do is to rearrange these terms so that it's going to be in this form. See, this is the key. You've got to get whatever the equation looks like, it's got to eventually wind up looking like that. And when it winds up looking like that, then you can factor it. So that's the first thing that we're going to do in this problem. We're going to take x squared 3x plus 10, bring over the 3x, bring over the 10, allow a little room here, which, we can do. And once again, the -3 goes on that side, the -10 goes over there. Okay, and this will become x squared minus 3x minus 10. This becomes 0, that becomes 0. So the first thing we've done is taken an equation not in standard form, as it should be, but we've converted it into standard form by bringing everything to the left side of the equation. And that's what we did here. And that's what we have right here. And now that we have that, we can continue solving it by factoring. And the factors of 10, that'll give us 3, will be 5 and 2, -5, +2. X plus 2 is equal to 0. X minus 5 is equal to 0. X is -2. And x is +5. And you could, check it formally. Just for your own purposes, you could check it informally. -2 squared is 4. 4 equals -6 plus 10. Well, that's right. 25, 5 squared is 25, equals 15 plus 10. And that's certainly 25 equals 25. So that works fine. And that's an example of solving a quadratic equation by factoring. Are there any questions? Okay, let's solve a different type of factoring. Let's say you're given x squared equals 64. Okay, solve that equation, please. That's all the time you need for this problem. There are actually 2 ways of solving this problem. And I'll do the traditional way first, and then show you another way. So x squared is equal to 64. According to what we've been doing, the first step is to bring over the 64 to the left side of the equation. And we get x squared minus 64 equals 0. This is the difference of 2 perfect squares. X and X, 8 and 8, negative and positive, or the other way around. It could have been positive and negative. It doesn't matter. X minus 8 equals 0. X plus 8 equals 0. X equals 8. X equals -8. Okay, that's one way of doing it. By the traditional way of first changing the problem into standard form. Doesn't look like a trinomial because there's no middle term, but it certainly is a quadratic equation. Now, the other way of doing it is to just look at it the way it is and take the square root of both sides of the equation. For this type of problem, where there's only two terms, as opposed to the previous problems where there were three terms, this problem can be solved this way. Just be careful, because x is equal to not only the square root of 64, but plus or minus the square root of 64, plus or minus 8, which we know is true because we got the same answer here, except we separated it into two parts. So the problem with solving the problem this way is you must keep in mind that when you get an answer, it's going to be one positive and one negative. But when you solve a quadratic equation, a second-degree equation, you're always going to get two values of x. That's the first method of solving a quadratic equation by factoring, and we're now going to go on to the second method. We only know of one method of solving a quadratic equation, and that's by factoring. So you're inclined to do this and figure out what this is. There's only one problem. You know what the problem is. Somebody tell us the problem.
So we need to find the common grand factor, basically.
Well, that's the method we know of. There's only one method we've studied so far, and that's by factoring. So, what are the factors? What's the problem here?
There are no factors that work for this problem?
Thank you very much. That was Talia, right?
Yes.
Good. Excellent. You can't factor this. This trinomial cannot be factored. No matter how hard you try, you can't factor it. Therefore, we have to come up with another method of factoring a trinomial. And the method I'm now going to show you is that method. And this is a little complicated, but very, very important. Not only is it important as a method of solving quadratic equations, but it's also important for something we're about to do next week. So you have to really understand the concept that I'm now going to be explaining to you, okay? And I just want you, if it were possible for you to drop your pens and pencils and just watch without taking notes. But, that's okay if you want to take notes. I'll try to go as slowly as I can, but this is very, very important. Okay, here we go. This is the method you use. And it's hard to justify any of this, but just watch and see what I'm going to do. The first thing I'm going to do is rewrite the problem. So we have the original problem to look at if we need it. Okay, so the first thing I'm going to do is bring this to the other side of the equation. Now, I know that this is unusual, to say the least, right? Because I've just told you that you try to bring everything to the left, but not in this type of solution. In this type of solution, when you're not factoring, when you're not doing it by factoring, you bring the 22 to the other side of the equation. Okay, that's step one. Step two. So let's say step one. Do that. Now, listen very carefully. We take half of 12. We take half of the x term. Half of 12 is 6. And then we square it and get 36. You'll see why in a moment. Don't say why, because we're going to explain why in just a moment. But I can't just add 36 to one side of the equation. Can't just walk over to an equation and say, here's 36. You also have to do the same thing to the other side of the equation. So I'm adding, now why am I adding 36? Well, I'm adding 36 because I know that I could factor this into 6, positive 6, and positive 6. Now I use factoring. So now that I've done this, adding the 36, which is incidentally step 2, I move to step 3, which is factoring this equation. And look what I get. So 2 things were solved by putting the 36 there. 1, we could factor it, but 2, the factors are exactly the same. That's important. Somebody want to say something? No. Okay. Again, not only does adding this 36 allow us to factor this trinomial, but by adding that 36, we actually use the same factor. Now, what does that do? Watch. This we could rewrite into x plus 6 to the second power equals 58. So this is called a perfect square trinomial. You know how we have perfect squares? The square root of 16 equals 4, because 4 times 4 is 16. Well, this is a perfect square trinomial because x squared plus 12x plus 36 gives you the same number. So when we take the square root of this, like when we take the square root of a perfect square, we get the same number, namely x plus 6. But you can't just take the square root of one side of an equation without also taking the square root of the other side of the equation as well. And remember, it's plus or minus the square root of 58. So once again, let me repeat what I said. We couldn't solve the equation because it couldn't be factored. So I brought this 22 to the other side of the equation. I then took half of 12 and got 6. I took 6 and squared it and got 36. I factored and got the same factor. That was the purpose of taking half of the middle term and then squaring it. That gave us the ability of factoring and getting the same factor. Here we are anyway. So it's the same factor. It's x plus 6 squared. We take the square root of both sides. This is where we are right now. In other words, x plus 6 is equal to positive the square root of 58, and x plus 6 equals negative the square root of 58. And we bring the negative 6 over, and that gives us x equals negative 6 plus the square root of 58 and x equals negative 6 minus the square root of 58. Now, the next thing we need to do is to find the square root of 58. So you need a at this point, we haven't used a calculator, but now you must use a calculator because x will equal negative 6 plus, now to get the square root of a number, you turn on your calculator and you put second function x squared. I haven't used this. Okay, here it is down here. Second function x squared 58 equals 7.6 to the nearest 10th. Excuse me, 7.6 to the nearest 10th. And over here, -6 minus 7.6. And when you work this out, you get x equal, well, you know, do it over here if you'd like. 1.6. And here, it's -13.6. Here are the two answers to the question. And if you'd like, I can show you in what a larger version of my calculator looks like. So,
Professor.
well, one second. I just want to make sure that you understand. So this is a large version of what my calculator looks like anyway. I turn it on, I go second function, x squared, and there's the square root sign. And then I press equals, and it gives me the answer. Okay, so once again, turn on the calculator, hit second function, x squared, put the number in, 58, and then equals, and that gives you the answer. Yes, was there a question?
Yeah, this is Valeria. So I am looking at the steps and I don't know where you got plus 33 on each side. Can you just go over that again?
I don't have 33 on both sides.
I'm sorry, 36, not 33, 36.
Do you remember when I took half of 12 and got 6?
Mm-hmm.
And I squared it and got 36?
Okay.
You can't just add 36 to the left side of the equation without also adding it to the right side of the equation. This method of solving an equation is called completing the square. Completing the square. And it's a very, very important concept in mathematics, not only for this course, but for, doing other things as well in mathematics. And we'll be doing this, we'll be using it to solve equations, and we'll also be using it next week, as I said, to do something else. Okay. Now I need to I think I need to erase it. Well, let's see if we can fit it in here without my blackboard sort of dropping on top of me. I'm going to give you a moment. I know that people are still looking at this and going, "What?" But I want to give you a little bit of time and see if you could at least start this problem. So solve this problem by using the method of completing the square. Let's begin. Okay, we have still have a lot to do today, so let's begin. I know that some of you are still working, but but some of you are not, so let's just begin doing the problem. Here's the problem. You come to the conclusion that it can't be factored, no question about it, right? So the first thing you do is bring the 11 to the other side of the equation. Okay, so that's step one. You want to bring that 11 to the other side of the equation. Once you determine that it can't be factored, then you bring it to the other side of the equation. Then you take half of the 6. Take half of the 6 and square it, and you get 9. And you add that 9 over there. So again, bring the 12 over, take half the 6. Half the 6 is 3. 3 squared is 9. You can't just add 9 to this equation without also doing it to the other side as well. Okay, now you're able to factor this into x plus 3 times x plus 3 equals 20. X plus 3 squared equals 20. So then you factor it, and it's, it's usually a pretty simple factoring. What you get, here we are right here, there's two of them, so we can make it, when you have 4 times 4 or 5 times 5, you can make it 4 squared or 5 squared. You get this. And now you take the square root of both sides of the equation, and you wind up with x plus 3 equals plus or minus the square root of 20. You bring over the -3. Now, so it's not right over there. I'm going to put it on the side, so it's kind of away from everything. And x will equal, now you bring it back, -3 plus or minus the square root of 20. So the two answers will be x equals -3 plus the square root of 20, and x equals -3 minus the square root of 20. And the next step is to take the square root of 20. So that's what I'm doing right now. Second function, x squared, put the 20 in, you must press the equal sign, and you get rounded off to the nearest tenth, 4.5. So x will equal -3 plus 4.5, and x will equal -3 minus 4.5. It actually comes out 4.47, which I rounded off to 4.5. Doesn't have to be absolutely precise. X will equal 1.5 positive, and x will equal -7.5. These are the two answers. And that's the end of the problem.
Sorry, Professor, I have a question. It's
Go
Elisa.
ahead. Go ahead.
So we should like round it like all the time, the number, or
Yes.
okay.
Always
you.
round to the nearest tenth. I will never require anything beyond to the nearest tenth. So even though the calculator is going to give you some long number, you always round it off to the nearest tenth. So let's just again go through the process. So you're given an equation which you determine cannot be factored. Bring over the 11. This is the problem right here. Bring over the 11. Take half of this number. Half of 6 is 3. 3 squared is 9. Add that 9 to both sides of the equation. Factor. Now you're able to factor it, and the factors must be the same. So x plus 3, x plus 3. That's why we take half, when we take half of this and square it, we assure ourselves that we're going to get two equal factors. And then, of course, you add the 11 plus 9 and get 20. Then you put these two together, you get x plus 3 squared. Then you take the square root of both sides of the equation. And when you do that, remember that you get plus or minus. Let me do that immediately rather than doing it in the next step. Let me make this plus or minus the square root of 20. Okay, so this is where I am. I got x plus 3 which is what we want to do here, equals plus or minus the square root of 20. I bring over the 3 because I do want to get the x by itself. So I got the x by itself, and it's negative 3. There's the negative 3 from over there, plus or minus the square root of 20, which I then separated into 2 parts. Negative 3 plus the square root of 20, negative 3 minus the square root of 20. I then take the square root of 20 to the nearest 10th, and I had x equals negative 3 plus 4.5, which came out x equals 1.5, and negative 3 minus 4.5, which I wound up with negative 7.5. And that's the end of the problem. That's solving an equation which cannot be factored by the method of completing the square. Let me write it here, because I don't want to go off the problem. Completing, the method is called completing the square. And when we talk about completing the square, this process of taking half of the 6, squaring it and getting 9, we're completing the square. We're making this into a perfect, we're making this trinomial into a perfect square, which we did. We got the same factors, and that's what we need to do. It's a very, very beautiful method of solving a quadratic equation. And you need to know this. Now, there's one more type of problem related to this that I'm now going to do. Now, once you've determined that this can't be factored, and I'm not going to let you like kind of work with it and see if you could do it, because just take my word for it, it cannot be factored. We proceed to do what we normally would do, and that is we go like this. This is the normal way of solving a quadratic equation by completing the square, right? Now, the problem that we are looking at here that we did not have before is that there's a 2 here. You can't use the method of completing the square if you have a coefficient greater than 1 in front as a lead coefficient. So you got to do something to get rid of that 2. And what we do is we factor it. Factor it out, pull it out. Okay, so I did nothing more at this point than factor out from these 2 terms, the 2. That comes out, there it is, right out there. We've gotten now a 1 as the lead coefficient, and we are now able to continue completing the square. So we take half of negative 8, which is negative 4, square it, and get positive 16. So, forgetting about this 2 even, we took half of the 8, negative 8, get negative 4, square it, and get positive 16. But we can't just add a number to the left without also adding the number to the right. But we're not just adding the 16 because there's a 2 in front here. We're actually adding to this side of the equation not a 16, but 2 times 16, which is 32. So again, once I pull that 2 out, it gives us the ability to complete the square, but the number we put there is not just a 16, it's 2 times 16, which is, we actually added 32 to the left side, add that to the other side of the equation, and here we are. Everything else remains the same. This is 25. Now the question you might say is, what do we do with the 2 now, right? What do we do with that 2? Well, I say when you have a 2 you don't need, divide by it, get rid of it. So I'm doing that. And I'm putting these 2 together and getting x minus 4 squared equals 25 over 2. And my advice is figure this out. Use your calculator, do the division on the side of the page, whatever you're going to do. You wind up with 12.5. Okay, so 2 into this is what I did. I just divided 2 into 25. And wound up with 12.5. And that's it, okay? Now you take the square root of both sides of the equation. You get x minus 4 equals plus or minus the square root of 12.5. Everything now flows exactly as it did before when we were solving the other type of completing the square type problem. We bring this over because we want to get the x by itself. X equals 4 plus or minus the square root of 12.5. And that's exactly what I'm going to do now, is find the square root of 12.5. So second function, x squared, 12.5. I actually closed the parentheses because there was a decimal point, and that equals, it looks like 3.5 to the nearest tenth. So this is 3.5, which makes sense because 3 times 3 is 9. 4 times 4 is 16. It's between 3 and 4. So 3.5 makes sense. So x equals 4 plus x equals 4 plus 3.5, and x equals 4 minus 3.5. 7.5 over here, and x equals 0.5 over here. And those are the 2 answers. And there's the complete problem from beginning to end. I know it's difficult. I know it's difficult, and I feel bad about that. But let's just go through it. So you have an equation that you've come to the conclusion cannot be factored. Cannot be factored. So you bring over the 7. You then do something you didn't do before, which is factor out the 2. Then you complete the square. Now remember, you can't use completing the square unless this coefficient is 1. So you factor out the 2, you get this. You of course, you're not just adding 16 to the left, you're adding 2 times 16, which is 32 to both sides of the equation. So I did that. I added the 32. Negative 7 gives us 25. Got rid of the 2 over here. Put these 2 together. Had the square root of x minus 4 squared equals the square root of 12.5. Wound up with this, brought that over. So it's quite a procedure, quite a procedure. And it needs to be studied. you can't just look at this the way it is now and say, okay, I know it. You don't know it. You have to really think about this, and you have to go through it again, at least again, and do it exactly the way I did it, step by step. Are there any questions?
This is Talia. I had a question, about how you got from 2x squared minus 16x to the parentheses with the 2 on the outside. For the negative 8x, is it because it's the 6
factored out a
divided by the 2?
I factored out a 2 here.
Okay, yeah.
It came from here. It
Okay,
came
yeah.
from factoring
And then
out
that's
the
why
2.
you did the 16, because it's the 4 is the half of the negative 8x.
Yes,
Okay.
yes, yes.
All right,
yes,
thank you.
exactly. You're welcome. Excellent question. So we are back. And what we've been doing for the first part of the class today is, other than reviewing the homework, was to solve quadratic equations by the method of factoring. When we couldn't factor, we were using a method called completing the square. Mathematicians came to the conclusion that completing the square was a lot, just very difficult to do all the time. And whenever you do completing the square, you keep following the same procedures over and over again. So when that happens in mathematics, mathematicians decide to derive a formula which can be used, which uses the concept of completing the square, but it comes out with a formula. And the formula they came up with was the quadratic formula. Now, I would love to derive this. As a matter of fact, I do derive it, but I do not derive it in class. Rather than that, I've derived it separately, and it's a separate video. So some students like to see the derivation, some students don't like to see the derivation. And for those of you who are interested, I'm going to give everybody the link, and you can either watch it if you want, or you don't have to watch it. It's not required. But some people people who are going to be studying higher mathematics are curious about what the method looks like. So I will simply give you the link to the video, which does completing the square to derive the quadratic formula. And you could watch it if you want, but it's not required, okay? But right now, I'd like to give you the quadratic formula right over here. Okay, so this is the quadratic formula. Now, we start with the general form for the quadratic equation. And the quadratic formula states the following. And this is one of the most valuable formulas in all of mathematics. And this is called the quadratic formula. This formula works for any quadratic equation, which makes it, therefore, extraordinarily valuable. If the equation can be factored or not factored, the quadratic formula will always give you the right answer. And right now, we're going to take a typical example, and I'm going to show you how the quadratic formula would come into play in this situation. Now, this quadratic equation that I just gave you cannot be factored. As a matter of fact, if we wanted to do this problem by completing the square, it would be very difficult to do that because the middle term is an odd number. So if you go back through the notes and you see the problems that I used to complete the square, you'll come to the conclusion that in every case, this was an even number. But in this problem, you can't factor it. It's an odd number, which would make it very difficult to take half of this number and then square it. You know, imagine doing all that work with fractions and all of that stuff. So that would be difficult. So the method that always works is this method right over here. So here's what you do. Here's the problem that you're given, and this is how you would go about doing it. The first thing you would do is identify, put a 1 over there if you'd like, but A is equal to 1, B is equal to 3, and C is equal to -1. We're going to need those, of course, because this is what the formula is taking into account. The formula is taking into account the coefficients. See, when you're solving a quadratic equation, it's not the x's that are important, it's the coefficients that are important. It's the coefficients that allow us to do factoring or completing the square. So we just take the coefficients, and that's what goes into the formula. Next step is to write the formula. -b plus or minus the square root of b squared minus 4ac over 2a. This must be memorized. Because, you know, I've memorized it because I've been using it for 60 years. But this is, you know, it's something you just have to memorize with use and with just sitting down with it and trying to figure it out. Now let's continue. So -b would be -3 plus or minus the square root of 3 squared minus 4. I'm just using the formula, A, which is 1, times C, which is -1. And everything is divided by 2 times 1. So all I did in this problem so far was to take the coefficients, substitute it into the quadratic formula, and it's not a bad idea to check yourself to make sure you've done it correctly. And that's what I'm doing now. 4 times 1, C is equal to -1. Don't forget that. And then 2 times 1. Okay, and now you go through the steps. Equals. So x equals -3 plus or minus the square root of 9. Now -4 times 1 is -4 times -1 is +4 divided by 2. So that's not a trivial step because you actually have to, you know, make sure that you figure out with all the sign numbers and everything. So x will equal -3 plus or minus the square root of 13 divided by 2. Now, in my opinion, the next thing you would go about doing is to find the square root of 13. So that's what I'm doing now. Take the calculator. Take the calculator. Clear it from the previous work that you were doing. Second function, x squared, and 13, closing the parentheses, and equals, and, you know, to the nearest tenth, which is what we'll always use, it comes out to 3.6. So this is equal to 3.6. So therefore, x will equal -3 plus 3.6 over 2, and x will equal -3 minus 3.6 over 2. these are your two answers, but you know, you should continue. Because there are times when we're going to be doing this and using this in actual problems, and you're gonna have to get an actual answer. So X will equal, now, you know, if you want to use your calculator, -3 plus 3.6 comes out to 0.6/2, which equals 0.3. So one answer is X equals 0.3. And X equals -6.6/2, which equals -3.3. So X equals -3.3. I'm just looking at this because it's, you know, there's a lot of stuff going on here, making sure I have the right answer. Well, it looks pretty good. That's it. That's the complete problem from beginning to end. Quadratic formula. Are there any questions? Okay, I'd like to give you one to try. It's slightly more difficult. Slightly more difficult. Okay, but here it is. So the question will be, all right, so I mean, this is the way I do it. Not, you know, this is just my method, is to first state the A, the value of A, the value of B, the value of C. And I'm just looking to make sure I have the right signs, which I do. So state the formula, -b plus or minus the square root of b squared minus 4ac over 2a. Then substitute in the formula -7 plus or minus the square root of -7 squared minus 4 times AC. A is equal to 2, and C is equal to -5. Divided by 2 times 2. Okay, so that's, you know, all you need at that point. Now, again, I'm just checking my work. So the formula says -b. So whatever b is, there has to be a negative sign outside of it. So it's -7 plus or minus the square root of -7 squared minus 4, which is in the formula, times a, which is equal to 2, times c, which is equal to -5. So I feel confident that I've done the substitution correctly. Now you have to evaluate this expression. X will equal 7, because the negative times the negative is positive, plus or minus the square root of 49, and that's 20 times 2 is 40, which is not what I want. I think we should just evaluate that as well at the same time. That'll save us a little time. Okay, so where did I get the positive 40 from? You might be wondering. And that's from -4 times 2 is -8 times -5 is +40. And that gives me, again, I draw a line, x equals 7 plus or minus the square root of 89 over 4. Again, draw a line. If you're taking a test, and this is a test question, it's always good to separate your steps. It helps me tremendously and will, assure you of possibly getting partial credit for this problem if you don't get everything right. X is equal to 7 plus or minus the square root of 89. So turn on your calculator. Second function, x squared, 89, close the parentheses, equals 9.4. Which makes sense. You do kind of a little bit of a check on your own. Like what's the square root of 81 would be 9. So it's going to be a little more than that because it's greater than 81. So 9.4 makes sense. Two answers. X equals 7 plus 9.4 over 4. X equals 7 minus 9.4 over 4. Okay, so we're still on the problem now. X equals 16.4 over 4. And here, 7 minus 9.4 is negative 2.4 over 4. Okay, both of these are divisible by 4, so that's very, very nice. I'm going back and making sure I have that correct. Again, as I said before, you could use your calculators for this. I'm just adding 7 and 9.4. That's kind of straightforward. This is a little more challenging, but that looks, that's the way it is. And this would become, here are your two answers. 4.1 and x equals negative 0.6. It's, it's straightforward. It's, if this is the first time you've ever seen this, it certainly is daunting because there's a lot involved. But it's not a difficult thing to use, but there are so many places where you can mess up. You could see all the different signs involved and the addition and a lot of this is really a very, very challenging problem. So this is a property in mathematics that I've used before, but this is the way I would start the problem. Since there's more over here than there is over here, rather than bringing these two terms to the left, this is the way I turned the whole thing around, put the 3x squared plus 1 equals x. All I did was turn the entire equation around. And now my next step is to bring over the x so that all the terms are on the same side of the equation, equals 0. And whether it can be factored or not at this point is irrelevant because the instructions say solve using the quadratic formula. So that's what you're going to use. And the next step is to indicate the value of A, the value of B, and the value of C. Then you state the quadratic formula. And I always, kind of, sit back, step back, and look and see what I've done so far. And you just don't do it at the end of the problem, but look, when you've done a few things, let's see if I've done them exactly the way I want. So -1, okay, that looks pretty good. All right, well, now we continue on. So let's come down here. X equals -b plus or minus the square root. Well, we did that already. I don't know why I'm writing that again, probably because it's getting late and I'm getting a little tired, but let's see, b is -1, so this is -1. I mean, don't forget that, this is -b, so if b is already -1, you put that in there, but still remember to keep the negative outside, which is part of the formula. And then plus or minus the square root of b squared, which is -1 squared, minus 4 times a, which is equal to 3, times 1 over 2a, which again, I did the same thing. 2 times 3. All right, and now draw a line, because I've done that. Now I need to really check it because I've substituted numbers in. It's -1, put that in there, plus or minus -1 squared, 4 times 3 times 1, okay, good. And then x is equal to 1 plus or minus the square root of 1 minus 12 divided by 6. Okay, now this is an interesting problem. Because you finally have come to a problem which does not have simply irrational roots, but also it's going to have imaginary roots. This is going to be an imaginary number because of that. So let's bring the whole thing up here where we have a lot more room. So I'm going to just rewrite what I have. So if you're looking and saying it's too, you can't see it. This is what I just did. And I'm just rewriting it that way. And this will give me two answers. This would give me x equals 1 plus the square root of -11 over 6. And x will equal 1 minus the square root of -11 over 6. And you can, keep drawing lines whenever you've separated concepts that you've completed. Now here, I would suggest just simply separating, taking out the I. I just took the I out, now it's just a regular expression. X equals 1 minus I times the square root of 11 over 6. Now, I guess you want to take the square root of 11, although you're not going to be able to get an actual answer here. But the square root, second function, x squared of 11. Square root of 11 is 3.3. So this is where we are right now. So let's put the 3.3 first, actually, right? 3.3i over 6. And x equals 1 minus 3.3i over 6. Now you're probably wondering, now what? And my suggestion would be, that's the end of the problem. I wouldn't go any further with this. Because you certainly can't combine, you can't combine this. And then to divide by 6 is, not going to help you any. So this is a good enough answer as far as I'm concerned, right here. And those are the two answers. And and I gave you this purposely because it gives you an imaginary number. And that simply means, take out the square root of -1 and you're left with the just the irrational number. Okay, so you've taken out the I and so on, and that's it. That's the end of the problem. From beginning to end. Very challenging problem. Are there any questions?